My name is Jess Martin. I am an applied researcher, which basically means into the future of computing, which basically means that I'm like bridging ideas from academia. Like I read papers for fun, but then I like land those papers, concepts into real systems that embody the things that are in those papers. My focus right now has been on application interoperability for the last few years. So there's been just so many talks that have been warming my soul over the last couple of days. And if you're interested in that topic, you should definitely like corner me, and we should talk more about it. But we'll talk a little bit about that today. Today, the framing for this talk is we're going to be talking about a last mile problem. And so I need to introduce what a last mile problem is for those of you who have not heard of it. Last mile problems are very common in telecom and logistics. It's basically when you set up this incredible network that's got all of this value in it, whether it's the internet spanning the globe with undersea cables and satellites beaming down information to different places in the globe. You have to get that information all the way to the user's premises. Like somebody's got to come out and work and like run a line from a telephone cable to the house so that you can actually deliver the value. Otherwise, you don't have the value. You've created the network without delivering the value. This is also used in logistics. There's a reason why Amazon bought trucks, because in the amazing logistics that they've put together with warehouses all around the world, they can't deliver the solution to the last mile. They can't deliver the real value unless somebody drives up your driveway, walks out with a box, and drops it on your doorstep. So that is the last mile problem. We're going to talk about one of those for local first. So you can go ahead and start thinking about what you think that might be. First off, a little bit about me. I've been doing a lot of software development for a long time, but in the local first software space, I've worked across the last 4 years on 4 different projects. Actually, I'll talk about a 5th one on the next slide, but starting with Croquet, which was like a synchronization network. Fission, I was working on their web native SDK, and Odd SDK as it was renamed. It's been fun to see some of my Fission friends at the conference this week. I worked on a tablet called the Daylight tablet, which some of you may know about. I helped build, architect the sync system for multi-device that they haven't rolled out yet, but hopefully will roll out sometime in the future. And then most recently, worked on DXOS, which is one of the many local first frameworks with an everything app attached to it. But the most recent thing that I worked on in the local first space was a thing called the local first landscape. You can go to localfirst.fm/landscape. You can go on your phone right now and look at it. It has a great mobile interface. I worked on this with my good friend and collaborator, Johannes Schickling. You guys might know him from like Live Store and from talking to you on Local First podcast about local first space. But what this references is that they reference that like surveys all the different tools that you can use to build local first software, and it breaks those tools down by capabilities of like, what does this tool do for me? How does it handle synchronization? Does it do networking? Are they end-to-end encrypted? And it allows you to like sort and filter and basically just kind of explore the landscape of tools that are available for local first. But the really interesting thing about this project for me was I got to do like a 6-month-long deep dive into the entire local first ecosystem. I looked at like 30 different tools. I talked to creators of many tools. I talked to the authors of the local first paper and talked about the capabilities that we might judge the local first software by. And so all of that, I think, uniquely qualifies me to build a local first scorecard for the entire industry. So that's what we're going to do in just a second here. If you've read the original Local First paper, which I won't ask for a show of hands, because as Peter pointed out yesterday, Ink and Switch is famous for publishing very long things on the internet that no one reads, but everyone talks about on Hacker News. In that Local First paper, there was this graphic, which I have on the screen right now. And what that graphic did is it took the Local First ideals, the 7 ideals that are in the paper, and it basically boiled each one of those down to like a very short phrase and then applied it to different pieces of technology. And it basically said, there were 3 options. There was a green check for, heck yes, it achieves this ideal. There was a yellow minus for, it's sort of there. And then there was a big red X for like, nope, doesn't do it, does not meet the ideal. And they applied this to individual applications. But what I want to do is apply it to all of us. Collectively, how are we doing as an ecosystem at building the tools that make it possible for us to build local first software? So Here's my scorecard today, and we're going to talk about it. These are the ideals from the paper. These are like in the table of contents. If you didn't make it past the table of contents in that very long article, you would have actually read this. Let's talk about no spinners. First off, local first software has actually gotten fast. Not all software. But if you were at Local First Conf last year, there was a lot of people walking around bragging about how fast their software was. And it's true. Like, Local First software feels really good. We have things like optimistic updates and all that kind of stuff. For this one, I think it's a solid check of, like, you can make fast software. Doesn't mean you will, but you can. Multi-device. How are we doing at getting device data synchronized across multiple devices on different platforms? Well, turns out we have an entire category of software now that solves this problem, and we're debating about which one is best, right? So yes, there are still hard problems in the sync engine category, and people are still debating about how best to do it. But as a developer today, if I wanted to build a local first application, I would have a plethora of choices for how to achieve multi-device sync. So I'm going to give us a green check here. More work to be done, but good work. All right, network optional. Most people immediately think about offline support when they think about this thing, and there are some tools that allow you to have like full offline support and achieve that experience. I think Aaron Boudman numbered them yesterday at 5, but maybe we'll have 6 by next year. But because there is an existence proof, network optional, that's going decently well. What's not going well is that if you read the paper, the local first ideal here is that you would be able to interoperate with people when there is no network. Right? And so this implies some sort of like ad hoc networking, peer-to-peer Bluetooth, something like that. We don't have that yet, so I'm giving us a yellow minus. It's getting better, but it's not there. Seamless collaboration. The last 6 years since the paper was published, there's been so much work on this. Hard work on CRDT algorithms, other methods of reconciliation. Matthew Widener's talk yesterday of talking about different ways that we might solve this problem. And even though it's still hard, it's so good that it's really become table stakes in a lot of application categories. If you tried to launch a productivity tool without some form of automatic reconciliation, you basically would fail. So there's more work to do here, and we need to extend the experience of seamless collaboration beyond things like coding and design tools, and Ink and Switch's Jacquard and some other efforts are trying to do that. But I give us a green check here because it exists, and we kind of know the shape of the problem, even as we get to the edge cases, so to speak. Security and privacy by default. I'm not the expert on this one. Brooks' talk yesterday is kind of like laying out the path. The way that I summarize where we are here today is we think we have a solution in principle, but it does not exist in practice. And so I'd give us a yellow minus on this one. All right, but what about these last two? You retain ownership and control, and the long now. Well, what did the original authors mean by these terms? Ownership and control is largely about agency. It doesn't necessarily mean open source. It just means that it's possible for a user to copy, modify, tweak, repurpose, integrate, remix their data, and that the software doesn't prevent them from doing that. No company should be able to restrict a user's ability to work with their data. That's what ownership and control is about. The long now is basically about agency, but forever. You should be able to continuously access your data over a long period of time. The way that we might achieve the long now right now is there are some common formats that are just so ubiquitous that they will live forever, even if we want them to die. Can I say amen to PDF, right? That will be accessible 100 years from now. But there are other file formats, other formats that are literally dead now. I have some files on an old hard drive that I recovered some of the things that I wrote in high school in a word processor called ClarisWorks. Did anybody write in ClarisWorks? Okay, there's a few hands. I'm not alone. You can't open those files today, guys. There is no software. There is no brew install where ClarisWorks to dock utility. It does not exist. And the only way to open those files is actually to run an emulator of macOS 7. So there are things that are dead formats. And, if we look at, there's some problems right now that if you think about it like a generic local first architecture, here it is. We'd have like device A, device B, some other devices as well. And Inside those devices, we're running local first apps. And then inside those apps, we have a data store, right? And that data is synced across those data stores by some sync server, or maybe it could be a centralized server. Doesn't really matter. It's being synchronized. But the user, they have the data on their device, but just because it's on their device sitting in like an OPFS thing inside their browser or sitting on a local SQLite database, do they have any more ability to copy, modify, repurpose, integrate, tweak, remix? Can they meaningfully change their data? When I really think about the local first ideals, I have to give us X's on both of these. It's not clear to me that from the time we published this paper in 2019 until today, 6 years later, that users have any more agency or control over their data, or that software is going to live any longer than it would have lived 6 years ago. So this, to me, is local first's last mile problem. We are getting the data all the way to the device. We've done incredible work to build this network, just like Amazon built a logistics network, just like we put like sunk tables under the sea to carry internet packets across oceans. But we're not doing the last mile of getting it from their device onto their premises. That's what the last mile is about. It's like driving by the house, but not actually bringing the package up to the front and delivering it. And that's where I feel we're at as an industry. So, quick show of hands. If you're an app developer working on a local first software, can you raise your hand? All right. Great. I'm going to stare at all of you for the rest of this talk. Because I believe that the last mile is the app developer's problem, not the framework. The framework is the network. It's doing the hard work of delivering the files to the user's device. But you, app developers, you have things that you can do right now, today, before Ceph Gentle reinvents the operating system. You can do things today that will actually make this ideal real in users' lives. All right, so to make this really tangible, I'm going to give you 3 levels of sort of agency that you can enable users with in your software today. You can think of this like progressive enhancement. Like you can add more and more and more agency as we go up. And those 3 levels are export to common formats, continuous export, and then bidirectional sync. So let's jump right in. Export to common formats. This should be table stakes. You should already be implementing this, right? Like, if you're not giving users an ability to export their data to their, what are you doing? This one should be fairly straightforward. So I'm giving you easy mode. The bad part about this one is this isn't really getting the data to the user's premises. In our analogy, this is kind of like putting a fetch your own data box on the telephone pole outside the house, and every time they want their data, they have to run out the front door and open the box and get the data and bring it back into their house. And then the next day when they need it, they're like, oh, I've got to go do that again. All right, man. You're not running a line to their house yet, but it's a start. So let's start there. But an important, an operative word in this sentence is common formats. Export to common formats. So there's many to choose from today: Markdown, CSV, PDF. The important thing is that you choose one that is appropriate for your user's use case. In other words, you need to know what other applications they intend to use their data with and choose an appropriate format for them. Quick aside, JSON is not a common format. Sorry, it is. Guys, JSON is a container, and without documentation, it's not much better than binary. So at least document. Choose one that's appropriate. Why common formats? I've stolen these graphics from Gordon Brander with his permission. It's from an excellent essay from his Subconscious Substack. But common formats become an integration point. If you want to connect 2 pieces of software like we do on the left here, you just have 2 connections. 3, you now have 6 connections. 5 pieces of software, 20 connections. It's n times n minus 1 to build connections between all those pieces of software. If you put one common format in the middle, then you only have to write conversions to and from that common format. So we should use common formats. Okay, you're telling me, okay, well, there's not a common format in my world. I'm building a local first Pomodoro app, and there's no .pomo standard. That's fine. Invent one and document it. Now. I know that as soon as I said those words, XKCD 927 jumped into your mind. Because when I say that, what most people do is they throw this up and they throw up their hands. Like this gets them out of the, oh, I don't have to do anything about that. We can't invent standards. Let's not do that. Turns out, let me give you a use case here. So Obsidian is a local-first note-taking app that stores all the files on disk. And they take this philosophy of file over app very, very seriously. And so when they were rolling out a whiteboard last year in February or March, there is no common format for infinite canvases. And so they, instead of just storing something and not saying anything about it, they invented one. They called it JSON Canvas. They put it online at jasoncanvas.org. They wrote a simple spec. They put some examples up there. And they said, hey, here's how we're doing this. We're storing it to the file system. Here it is. What this enabled is that just a few days after JSON Canvas, or after Obsidian added that functionality to their tool, Canopio, which is another whiteboard tool that's very similarly simple as the Obsidian Canvas is, was able to add export and import to JSON Canvas. And all of a sudden, you have two tools that can talk to each other, just because they did the extra work of documenting their file format. It turns out that it's JSON, but it's documented. All right, let's see. So next level from there is continuous export. I think people overlook this one a lot, but this is basically, you can think of this as like a continuous projection of the app's data to an external source. Basically, every write in the app causes a re-render of the projected data. This doesn't even handle reads yet. It just overwrites it. In our analogy, this would be like running a single line to the house that is the read line. And it's like, great, I no longer have to walk out of my house to the box and retrieve my data. It comes straight to me. I can't write yet, but it's OK. I can actually do some reasonable stuff with it. Let's see. Quick demo and toggle mirror displays. Failed to toggle mirror displays. Let me try this then. Let's see. All right. Whoop. All right, can you guys see that? Nope, not yet. Let me try one more time, sorry. Hey, there we go, cool. Apparently if you tell it twice, it works. All right, so this is Obsidian. Every week, I actually like to plan my week in Obsidian, which is just it's like a to-do list, but I can use Vim key bindings to add new items and that kind of stuff. It feels really nice. But throughout the week, I actually like to visualize my to-dos on a Kanban board. I'm a very visual person, all that kind of stuff. So I wrote this little utility that I've been using for a few years now that reads my Obsidian file and turns it into a Kanban. And that makes it really fun for me, because I can check things off, and I can see them move across automatically. This is just using the file system APIs in Chrome. There's nothing fancy here. It's a tiny little Svelte app. I haven't changed it in 2 years, and it still works just fine. And the great part about this is Obsidian's choice to project their data onto the file system and to continually keep those files updated allowed me to build a read layer on top of that file system that was custom to me. And yeah, permissionless integration. Super fun. So, all right, let me see. I'll try toggle again. Hey-o. All right, great. Back to here. Cool. All right, I guess another point about continuous projection, we've had some conversations in the last hour about files, whether they're great or horrible. It doesn't have to be files. So here's an example of linear over here on the left, which thanks to Thomas for building some great software. And on the right, there's Google Sheets. And Linear built a feature that does continuous projection of your linear issues onto Google Sheets. So over in the top right-hand corner, I've got some issues. I'm going to hit refresh. You'll see 3 more appear. Down in the bottom right, I've got another sheet that builds a little dashboard for my issues. It's not a dashboard that's built into Linear, right? But it stays up to date. I'm going and changing the status for some issues. I'll go over here in just a second and resync them, and our dashboard updates. Magic, right? I was able to extend Linear's feature set because they have a read replica that is continually synced to Linear. To Google Sheets. Pretty fun. All right, level 3, bidirectional sync. This is pretty interesting. It's basically continuous export, just like we were just talking about, but also update from external source. This is like running the read and the write line to the house. Of like, now I can actually, I have the data on my premises, and if I change it, it changes everything else as well. This actually, all right, let's try this again. Boop, boop, over here, Command F, toggle, boom. All right, so Obsidian actually implements this, and that means that I can do this as well, which is always very satisfying to say, like, I want to mark something as done. So you see these things automatically updating over here in Obsidian, and that's because Obsidian isn't just doing a projection. They're actually using the file as a storage container, which may be ill-advised, but it did allow me to build this. So when you do implement this, you get some pretty fun things. But unfortunately, welcome to hard mode again. I did say that this was for app developers, but this is the little part that's for you people who are building other things than apps. Yeah, this is actually a really challenging research problem of what should the substrate be. We just showed one with files. Files have problems that all of you have already detailed for me over the last little bit, so I don't have to talk about it, which is great. But yeah, we need to figure out how to make this happen. But when you do make this happen, you can do some pretty magical stuff. So let's look over here. So over here on the left, I've got TL draw. So let's draw a TL draw rectangle that says, I'm over here. TL draw. All right, and over here on the right, I've got, what is that over there? Obsidian, and where did it go just now? Yeah, that would be bad. All right, there we go. Obsidian is over there on the right. Okay, cool. And then, yeah, I'm Obsidian. I can make the change on the right. You notice there's a little bit of a delay, and that is because of file system limitations and flushing, my friends. All right, I can draw an arrow. It comes over here. I can move things around. This is pretty cool, kind of real-time-ish. So I've got two different canvases that are interoperating. And you get bidirectional sync. I can make a change on one side. It's pretty slow over here. I was noting I was going to do like a little demo of how awful the arrows are in Obsidian, just as a hat tip to Steve. But yeah, good job on the arrows, Steve. What's going on here? Oh, thanks. Thank you. So how did that work, real quick? Like I did mention that Obsidian released this thing called JSON Canvas. Like, did Steve add support for JSON Canvas? No. So a year ago, when they released JSON Canvas, Orion Reed said on Twitter, he was like, hey, we basically, Orion and I were both doing some stuff with file export related to infinite canvases. We were trying to give users agency over their data. And we're like, great, there's a format, JSON Canvas. Yes, let's use it. Like, use common formats, people. But it turns out that JSON Canvas is very minimal tied to Obsidian's use case, and it's not extensible. And so Orion said, hey, you know, like maybe we should make an extensible version of this that we could all adopt, and then we'd have all these different tools talking to each other. And I said that would be great. And the Open Canvas working group was born. This is a picture from last year at Local First Conf, Expo Day, sitting outside. Some people will recognize the desks. The building was right over there. Somebody was showing a demo in that building at that time. This is us writing the first lines of a new spec for a new format called the Open Canvas Interchange Format. Over the last year, the Open Canvas Working Group has met 25 times. We've gone through multiple versions of the spec, some of which you can see listed there. I should have updated this screenshot because 0.5 dropped today. But we now have several people have implemented this in some of their experimental canvases. There's been some really great collaborators that have joined Orion and I that have helped with the spec writing and some of the integration work. Really massive props to that community. So how that demo was actually working was not TLDraw talking to Obsidian, right? That would be back to our fail case of like one-to-one. Instead, we use a common format in the middle where TLDraw knows how to read the OCIF file and update its store and write to the OCIF file. And similarly, Obsidian, we know how to write from Obsidian to JSON Canvas and back again. And so now you have this like magical property where you can like render OCIF in a lot of different ways. Okay, last thing. Humans aren't the only readers here. So if I wasn't convincing enough as it is that you should use common formats, LLMs understand open formats really, really well. So one of the things that we found that was kind of surprising is that I could actually ask an LLM to generate OCIF files, and it can do a pretty good job of that. So let's see. Show me a diagram of the major branches of government in the US and maybe the title of the director of each. All right. All right, so we're going to ask an LLM. We're basically, with this little request here, I'm giving a prompt to an LLM and saying, generate a diagram for me, and I'm giving it the OCIF spec, literally just the entire spec file. Like, hey, read the OCIF spec, make something like this. There's nothing special happening here, like it's not a fine-tuned LLM. I haven't even given it any examples beyond what's in the spec file. Here's the JSON it generated, and then here's an SVG. We have the U.S. government, the legislative branch, the executive branch, the judicial branch, Chief Justice, President, and the Speaker of the House. So you should use open formats for LLMs as well. The last announcement I would make is that OCIF is at candidate recommendation stage, which basically means that we feel really good about the specification. Feel like it captures the majority of use cases that we think people will have, but we don't know that until a whole bunch of people implement it. So if you are a Canvas author or you are working with a Canvas, you should go give OCIF a try. It's pretty great, and you could integrate with an entire ecosystem. So that's it. That's what I've got for you guys. If you're an app dev, it's up to you guys to take us the final mile, the last mile. Export to common formats, continuously export, explore bidirectional sync. It might be hard, but it's worth it. And if you're a Canvas dev, try out OCIF.